people who don't have the time to show up can take a peek at it later. Let's suppose we have something like this. Oops, might help if I had this right here. Y equals 3 secant of, let's do 2x. And I asked you to find the asymptotes for that. Well, secant is what over what function? If I was to write this,
1 over cosine?
It's 1 over cosine. So I could write this as 3 over the sec, or excuse me, 3 over the cosine of 2x. So let's do that. Cosine of 2x. Now the vertical asymptotes here are going to occur where the denominator is 0. So basically I want to know where cosine of 2x equals 0. Now, a long time ago, I asked you to memorize this kind of problem. What values does cosine equal 0? Well, let's figure out, first of all, where cosine does equal 0. Cosine is which coordinate on the x, or on the x-axis? Never mind. Cosine is the x coordinate of your point on the unit circle, right? So where do you have x coordinates of 0?
Pi over 2 and 3 pi over 2.
Beautiful, right here and right here. So in general, that's going to equal 0 when this angle equals the inverse cosine of 0, or you could write it generally as pi over 2 plus n pi. And that's where this is going to equal 0. So are you okay with that? So pi over 2 is the first one, and then n pi over 2. Well, really, that's just adding another unit of pi. So when n equals 1, then you're down here at 3 pi over 2. If n equals 2, you're back up at pi over 2, and so on. You're just going to keep on going back and forth between this one down here and this one up here. So I'll pause here for a second. If this isn't terribly clear, then we can go over it some more.
Hold on, I'm lost.
Okay, I'll tell you what, let me write it in terms of degrees. Pi over 2 in terms of degrees would be what?
90.
90. And pi is, anyone? 180. So in terms of degrees, what this is saying is that cosine is going to be 0 anytime you have a 90-degree angle or something that's 180 degrees or a multiple of 180 degrees away from that. So let's make a little chart here for ourselves for n and for theta. So I'll start out with n equals 0. N equals 0 gives me 90 degrees, right? Can you plug in n equals 0 here? What about n equal 1? Now what am I going to get? Well, 90
plus 90.
And what's that?
It's going to be 270.
270, good. Let's keep going. If I add 2, then I'll get 450. If I add 3, I get 630 and 910, or excuse me, 8, is it 810? Yeah, it'd be 810 next. But the point is, let's take a look at what's happening. So those points start out up here at 90, and then we're down here at 270, and then you're back up here at 450, and then 630, 810, 990, etc. So basically you're just bouncing back and forth between these 2 points. And both of them have a cosine of 0. So basically what this is, it's a general expression for where the cosine is 0. Here's that same general expression just written in radians as opposed to degrees. So are you feeling a little bit better about that now? Alfonso?
Can you
You
do
feeling
a
okay
different
with this?
example? Yeah, I'm just saying, because when I went back to my notes, you did 2x equals to n pi. Then we're trying to make x be by itself, so we can
Right.
have that
X
formula.
equals n pi, that would probably be because you had a sine term in the denominator, and sine is going to equal 0 at multiples of pi. So at 0, pi, 2 pi, etc. So the green points here as opposed to the one circled in blue. So yeah, that's a kind of a good thing to know, is where does sine of x equal 0? Where does that happen? When x equals a multiple of pi, n pi. So that's why I'm using something different for that one. But what is consistent with what you just said is that I tried to get x by itself. So let's take a look at this one and see what I can do to get x by itself. Most of us would probably divide by 2. I'm going to just multiply by the reciprocal because I think the algebra works out a little bit easier. So if I multiply both sides by 1/2, what do I get on the left-hand side? Okay, make me look good. This is going out on YouTube. All right. That would be an x. And let's distribute this term here to both of these terms here. That's going to give me pi over 4 plus n pi over 2. Now, if I was working in degrees, if I multiplied everything here by 1/2, I'd end up with 45 degrees plus, well, divide that by 2, it's going to give me n times 90 degrees. So at these points, multiples of 45 degrees, or 45 degrees plus multiples of 90, you're going to get a vertical asymptote. Or in terms of radians, you're going to get vertical asymptotes here at 45 degrees and every 90-degree angle afterwards. So,
what are you doing?
Say again?
Oh, I was talking to Johnson. Sorry, that's my dog. Sorry.
Hey, Fido. All right. So let's take a look at the B. Let's see, can we at least do n equals 0? What's n equals 0 going to give me for x?
Pi over 4.
Pi over 4, which is 45 degrees. At n equal 1, then I'm going to get 90 degrees plus pi over 4. That's going to be over here. And then n equal 2, and n equal 3. And after that, you're going to start repeating yourself, getting all these angles, just, bigger and bigger coterminal angles from there. So,
Okay, so it's going to be different from secant and cosecant, the way that you get the asymptotes. So it's
yeah, well, it is and it isn't. I mean, the general way is you want to know, where does the denominator equal 0? So that's what I started out with. Now, if you get a cosine term here in the denominator, then cosine is equal to 0 right here at pi over 2 plus multiples of pi. If you're dealing with a sine, and boy, hard to believe I'm running out of different colors of ink here. If you're dealing with a sine, then sine is equal to 0 at multiples of pi. So it's these two things that I would definitely have memorized. Where does sine equal 0? Where does cosine equal 0? Now, let's do one last thing here. And that is, let's kind of see that in action. So I'm going to open up Desmos. And so my function was y equals 3 secant of 2x. And it gives me something like this. And let me kind of try and squish the graph a little bit and then squeeze it out a little bit. There. Good enough. So we're getting asymptotes at multiples of 45 degrees. So let's get rid of the minor grid lines. There we go. Clean that up a little bit. And I'll put a step at pi over 4. So with that little change here to our graph, can you see that at pi over 4, 3 pi over 4, 5 pi over 4, these are all going to be your vertical asymptotes for this graph. And that's exactly what I was saying. It's like, okay, right here, pi over 4, 3 pi over 4, 5 pi over 4, and then 7 pi over 4 is going to be the last one before we get to 2 pi. Good question. Good question. There was a lot there. So if you want to follow up with something, well, let me know. All right. Yeah, go ahead.
No, I'm just trying to make sense of it.
Okay. Is there anything I can help out with? Any details?
Can I tell you the way I solved this problem in particular that I have?
Sure.
And you tell me if it's valid or not. The
Okay.
problem is y equals -4 cosecant of 1/3x.
Okay.
And the way I did it, I put 1/3x equals to n pi.
Yeah. Well, let me give you a reason for that. I mean, but that's essentially what you want to do. So this is -4 over sine of 1/3 x. Now, I said just a minute ago that sine of x equals 0 when x equals n pi, right? And when we're looking for where the asymptotes of this function are, we have to look, well, where does that equal 0? So in other words, where does the sine of 1/3 x equals 0? Or, rewriting it this way, x equals sine inverse of 0. In other words, wherever the sine is 0. So it's going to be 1/3 x equals n pi. And then to solve for x, you multiply both sides by 3. You get 3 n pi. So basically, multiples of 3 pi, if you want to think of it that way. 3 pi times n. So if I was to look back at a graph, then every 3n pi, I should see a vertical asymptote there.
Got it.
All right, so yeah, what you did was fine, and I hope you have a more complete understanding of that now.
Yep.
Good, good.
So if I want to graph it on the test, should I just plug in -1, 0, and 1, like the numbers that are more convenient for me to just show like 3 or more?
You mean define like the asymptotes?
No, like in the graph, because it gives you like a graph. So you do the asymptotes and then do the lines.
There's a two-part problem there, yeah. So what's going to happen, and I'm going to kind of cheat a little bit and go over to Desmos, but what's going to happen, let's take a look at this in a couple little parts. So the first one I want to look at is cosine of 1/3 x. And that's kind of a lazy function because that 1/3 divides your period. And then let me multiply it by -4. So what's the -4 going to do out in front of this? How's that going to affect the graph?
Flip it.
It's going to flip it. And it's going to stretch it. What's the amplitude of this graph? That's a good question here.
Is 4? Oh, I'm sorry, no.
No, the amplitude is 4. It's the absolute value of this number out in front here. So cool. So now what I want to do is I need to take the reciprocal of this graph. So I did a couple things the 1/3 sort of stretches out the period. It doesn't go up and down as fast anymore. By the way, how do you find the period of this graph?
That will be 2 pi, the period over 2 pi.
Well, 2 pi divided by the coefficient in front of.
Oh, yes, I'm sorry, I mixed it up.
Basically 6 pi is what's going on. So this graph should repeat itself every 6 pi. So if I start out here at 0.4 and I move over 6 pi, what's happened? The graph starts to repeat itself.
Okay.
You're in the same spot. Now, that's the period. The frequency is the reciprocal of that. So 1/6 pi, 6 pi, that's going to be your frequency. It's basically how fast it's oscillating up and down in 1 unit of time. But let's get to our graph. I know I have asymptotes wherever this is 0. So here and here and here. And let's see that when we graph it. So if I graph y equals -4 secant, was it secant or cosecant? No, we had secant, right?
Cosecant.
It was
Secant? Ah, okay.
Was it?
Cosecant.
Yeah, it was cosecant. That makes more sense. Y equals -4 cosecant. Let me just change this up to a sine. Sine. There we go. That's going to match our desired asymptotes of 1/3 x. And so what you're getting is kind of the opposite of what the sine graph is, right? The sine graph is this wave in between. The secant or cosecant graphs are going to be graphs that just touch at these peaks and troughs and then turn away. And they're going to have the asymptotes that we thought. So let me think here. Let's do this, -10. And I'm just going to try something here. X equals, let me call this something. C. 3 pi c. There we go. There's all our, yeah, there's our vertical asymptotes. Yeah. Nice. Are those over? No, that's not right. Oh.
-6, -3, 0, 3, and 6. Yeah,
That's
right.
Yeah, okay. Why is that not looking right? Okay, I guess because you keep on looking at the sine graph. Let me get rid of that. There we go. Beautiful.
Yeah.
So the one thing that I'll be looking at in terms of your graphs pretty closely would be, you know, how far down this comes. And this should come down to a 4 and up to a minimum of, or a maximum of -4. So that's, you know, something I'd probably pay close attention to when I'm looking at your graphs. Of course, keep in mind you have all kinds of technology to help you, so this should be okay.
Got it. All right.
So the first thing to do is to find theta, and we can do that by using the inverse of 0.25. And for that, probably want to go to your graphing calculator. Now, what mode do I want my graphing calculator in?
Degrees.
Degrees. Good. So currently I'm in radians. Let me switch and come down here or to degrees.
Technically, can you work this problem both ways, right? You can.
Well, but the
no.
inverse sign, you know, is going to give you different answers when you use degrees versus radians.
Right.
So now I want it in degrees because my answer is supposed to be between 0 and 360. So, but you can work it in either one. You just got to be mindful of what the problem is asking.
Okay.
So the inverse sine of 0.25 and about 14.48 degrees, we'll call it. All right. So let's put that over here. So that equals 14.48. Now let's keep in mind what that's really saying here. Because if you stopped with just that, you're going to get 2 points out of 4 or 4 points out of 6. I mean, 3 points out of 6. Because keep in mind what that's saying. Up here, right here, this is saying that the y value is equal to 0.25.
Oh, I remember these.
All right, there we go. So y equals 0.25. And what we just found out is this angle right here is 14.48. But is that the only place that has a y coordinate of 0.25?
No, the other side.
Yeah, there's one on the other side. So right over here. And now this angle over here mirrors this one over there, 14.48. So the question is, if I were to start out here on the x-axis and go over to here, what would that angle be? Or how could I find it?
180 minus 14.48.
Mm-hmm.
Perfect. And so that gives me my other angle, which is going to be 165.52. I think. I don't know. Don't trust my math. Okay. So yeah, there's 2 solutions, and there they are. So that's a good one. Definitely, I'd recommend you looking at that one. In fact, it's kind of relevant to another example that I wanted to go over. See, and I'm not sure who's kicking around there in the background, but keep it to a lower roar, that would help out. I don't want to mute people because I want people to be able to chime in with a question. But suppose I gave you a problem like this for one of these solve for the triangle problems. A equals 4, B is unknown, C is 8, and that should be an alpha, not an A. Alpha is, let's say, 13. Beta and gamma are unknown. And I asked you to solve for the triangle. Okay, a reasonable problem. How would you start it?
The law of cosines? No.
Law of sines.
I'm sorry, sines. I
Law of
got
sines.
confused.
All right. Law of sines, because you've got an angle and opposite side pair that I circled in yellow. So we'll use that. It's going to be sine of 13 over 4. So sine of 13 over 4 equals
I hit him back.
Gamma over 8. So 8 sine of 13 over 4 equals sine of gamma. Let's see what that gives me. That's going to be, gamma is going to be 2, or sine of 2 sine of 13 equals sine of gamma. So let's figure out what that is. And I'll go back to this over here. So 2 sine of 13, 0.449, 0.4499. All right, call it 0.45. Yeah, I call it 0.4499. So let me go back here. 0.4499 is sine of gamma. And now what? Well, now you do sine inverse of 0.4499 and you get gamma. Okay. What are our options? What angles match that? And this is where the previous example is nice and helpful, is a nice lead into this one. So thanks, Alfonso. Let's do the inverse sine of that. So I'll do second sine, second answer. Oops, let's back up. Second sine, second, answer. There we go. I just must not have hit it good enough. So one possibility is 26.73 degrees. But the other possibility is 180 minus that. So 180 minus that is 153.26 degrees. Okay. You know what? This isn't going to work out as nice as I wanted. All right, so 26.7 and 153.3. 26.7 or 153.3. Now, how many triangles could I get out of this? Am I going to get one possible triangle or two?
Two.
Two, right? Because remember, these things have to total up to 180. And if this one's not that big, then it's going to leave room for a very slender gamma. So if this angle is too big, then you're not going to have room for a gamma. They're not going to be able to find something so that it totals up to 180. But in this case, it's small enough that we get two angles. If it's too big and this angle is too big, then yeah, then you're out of luck. So that was the point that I wanted to get to, is that you're going to look at the size of this and see if the second angle is too big to add up to 180 with the other angle that's there. So that's a good one. I would definitely make sure you understand that before, I don't know, tomorrow. So if there's something that's not clear about that, let me know. That's definitely the example that I wanted to get to, although I kind of wanted a different outcome here. I wanted something that wouldn't work, but you know, hard to always hit it right when you're doing these things off the cuff. All right, keep that one in mind and around. Practice it and make sure you can explain it in words. Zoom. So if I want to find the points to use to graph this with the 5-point method, then I got to find the points that are eventually going to lead to the nice easy places like 0, pi over 2, pi, 3 pi over 2, and 2 pi. So one way to do that is to start out with this. 0 is less than or equal to 4x plus 2 pi, and that's less than or equal to 2 pi, and then solve for x. So the first step in doing this is to subtract 2 pi from all three parts of the inequality.
Got it.
That gives me negative 2 pi. Why isn't this writing? There we go. Negative 2 pi is less than or equal to 4x is less than or equal to 0. What's the last thing I need to do to solve for x?
Divide by 4.
Divide by 4. So we'll divide everything here by 4. And I'll do the right-hand side for us. That gives us a 0. I'll even do the middle. How about on the left-hand side? Negative pi over 2, right? So that's points 1 and 5. And what we're going to want to do is fill out a little chart. All 5 of those points, 2, 3, 4, and 5. So 1 is negative pi over 2, and then all the way up to 0. So what we need to do is we need to figure out, well, what are these middle points? For instance, what's in the middle of negative pi over 2 and 0? Well, how do you find a middle point? You add them up and divide by 2. So let's do that. Negative pi over 2 plus 0 divided by 2. And just a reminder here, when you divide by a fraction, I'll think of the 2 as 2 over 1. That's like multiplying by the reciprocal. So it gives me negative pi over 4. Okay, that's the next one, negative pi over 4. Now I need to find the average of points 1 and 3 and repeat this process. So let me go back here and do that. Negative pi over 2 plus negative pi over 4 divided by 2. This one's a little messier. Let me think here. Probably the most efficient way to do that one would be this. Negative pi over 2 minus pi over 4 over 2 over 1 is to multiply everything through by the lowest common denominator. And that'll give me 8 in the denominator. And what happens when I multiply here? Those will cancel. Negative 2 pi. And then here, that'll cancel and give me negative pi. So I get negative 3 pi over 8. So negative 3 pi over 8. And this one would be negative pi over 8 if you took the time to do that one. Now, something that's reassuring about all this is the pattern that emerges. If I gave these things all common denominators, this would be negative 4 pi over 8. And then this is already negative 3 pi over 8. And this is negative 2 pi over 8. And that's negative 1 pi over 8. And of course, that's 0 pi over 8, or just 0. So all these line up nice and neatly. Except my feeling is a lot of people would struggle with the arithmetic part here. So let's make this easier, okay? And the way we're going to make this easier is we're going to do this part right here in degrees, and then we'll convert back to radians. So if I was going to write this in degrees, it would look like this. 0 is less than or equal to 4x plus something less than, well, let's think. 2 pi in degrees would be what angle? Anyone?
360.
360. And there was a 2 pi here, so I'm going to replace that by 360. And let's play this same game again, except it's going to be a lot easier because we're going to be working in degrees. So I'll subtract 360 from all 3 parts of this inequality and get negative 360 is less than or equal to 4x less than or equal to 0. Dividing by 4, negative 90 is less than or equal to x less than or equal to 0. So let's start working with our points again. There we go. So point 1, 2, 3, 4, and 5. So that one's negative 90. That one's 0. Can anyone just look at this and tell me what's in between negative 90 and 0? What point? In degrees.
Negative 45.
Negative 45. And this would be negative 22.5. And this would be negative, 67.5. just averaging those. And I trust that you can average those. So negative 67.5. Now the trick is to convert these back to radians. So let's do that. But we're gonna help ourselves out. You remember how to convert back to radians. These are all in degrees now. If I wanted to convert this to radians, what do I have to multiply by to convert it to radians?
Pi over 180.
Times pi over 180. So let's do that on a graphing calculator, and I'll show you a trick. And it's going to make this a lot easier. Let's take an ugly angle here, like negative 67.5. Now, to convert this to radians, I have to multiply by pi over 180. But here's the trick. Let's just leave the pi part out. So I'll multiply by 1 over 180, or just divide by 180. And then I'm going to hit the math key and press enter twice. Oh, so what's that? It's negative 3/8. So bam. Let's go back to this, and that was negative 3/8, and then I'll throw in the pi. And that's negative pi over 2. And this one you should know is negative pi over 4. This one you can get is negative pi over 8, and then 0. So I kind of like this. There's other ways you can do this as well. The bottom line is it's not really a fun problem. And no matter what you do, it's going to be a little bit of a pain. But that's why I give you a lot of points when you get this one right. So are you following me with this one?
Mm-hmm.
Anyone have a little uncertainty? Okay. Now the rest of this problem is going to look like this. Let's go back to, is it here? All right. Let's go back to here. And let me erase this stuff, since it's kind of redundant anyways. The rest of the problem would be, let's take a look at 4x plus 2 pi. Okay, so just the inside of the sine or cosine function. And if you did your work right here, you should always get these points. And you know what, let me put them here. 0, pi over 2, pi, 3 pi over 2, and 2 pi. Now you can check it by substituting in some things. Like at the bottom here, if I substitute in a 0 into 4x plus 2 pi, well, 4 times 0 is 0, plus 2 pi is 2 pi. You could check something like this one. Negative pi over 4 times 4 is going to mean negative pi. Negative pi and 2, excuse me, negative pi and 2 pi gives me pi. So that all checks. Can anyone suggest what the next line is going to be, next column?
Cosine of.
Yes, cosine of all that. So let's go here. Cosine of 4x plus 2 pi. You don't have to look back at the beginning here. You're just going to look back at the second column here. What's the cosine of 0?
1.
1. Cosine of pi over 2?
0.
0. Negative 1, 0, and 1. What's the next column going to be?
2 cosine?
Yeah, twice this column. So it's going to be 2 cosine of 4x plus 2 pi. And that's just going to be 2, 0, negative 2, 0, 2. All you're doing is you're doubling the previous column. There's one last column, and that last column is going to be your y value. And that's going to be 2 cosine of 4x plus 2 pi plus 1. So somebody finish off that last column for me. What's that going to be?
3, 1, -1, 1, and 3.
Perfect. And so when you graph it, it's just going to be this column and this column. So this is your X over here, and this is your Y to the right. So beautiful. I kind of suggest that you get those 5 points maybe by using degrees and then converting back. So, you know, maybe that's a little bit easier. Maybe you're good enough doing it the regular way. But make sure you're good at finding these points in radians. Thank you. Appreciate that question. So the way to do this one with what's given is this, the area, let's try that again. Area equals 1/2, let's see, it's 1/2, yeah, AB sine gamma. So in this case, it's going to be 1/2 of 6 times 4 times sine of 30. I hope you know what the sine of 30 is. Anyone want to make me look good here?
1/2.
Thank you. So the area would be 6. So that's one formula that you can use to find the area of a triangle. Now there's another formula that you can use when you happen to have all 3 sides. So if I knew the third side here, maybe the third side is C equals 7 or something like that. But if I have the third side, then there's Heron's formula. And that was a brief section that we covered earlier in this course. And Heron's formula looks like this. You're going to start by calculating what's called the semi-perimeter. That's 1/2 A plus B plus C. And then the area is this. It's 1/2 of S times S minus A times S minus B times S minus C. So there you go. Now, if I was implementing this for a problem like this, let's say that these were my sides. I'm not even sure that that would actually form a triangle, but let's assume that it does. Then to implement that, you'd have to have S equals 1/2 of 4 plus 6 plus 7. So it's going to be 17 over 2. What I like to do is I like to do that on my graphing calculator like this. So I'll take 17 divided by 2 and store that in X, like that. And let's just clear this out here, there. And then what I can do is take the square root of, well, basically I'm going to have an X where Heron's formula has an S. It's going to be X, parentheses, X minus 4, and then X minus 6, and then X minus 7. And bam, there's your area. So it's a nice formula, but to use Heron's formula, what you need to know is the length of all the sides. If you don't have the length of all the sides, then you can use this formula for the area. The product of 2 sides times 1/2 times the sine of the angle between them. So 2 formulas. And I would definitely make sure that I know both of them. Cool.
Okay.
Wonderful. Well, thank you so much, and good luck for your test. Try and get any last-minute questions answered if you have some tomorrow. But other than that, that's all I got right now.